All right, let's look at another solving problem with a logarithm. This one, first thing I think about, I have logarithms on both sides. Because I have logarithms on both sides, that means I need to condense them down to one on each side. This side is an addition, so I can use the product rule. The product rule says that I can multiply this argument by this argument. Once again, because this is a binomial, I am going to be distributing my x in. So that is going to give me the log of x squared plus x. Over here, I have division. Division says the quotient rule. So that's going to be the log of 4x over 2. So that part, just using my properties, condensing each side down to one logarithm. Now, the next thing that I notice is that I now have a log on both sides, just one. They have the same base. And so we can actually just take their arguments and set them equal to each other. So x squared plus x equals 4x over 2. On this side, I can simplify that. 4 divided by 2 is 2. So I'm just going to rewrite this as x squared plus x equals 2x. So once again, all I did here was 4 divided by 2 to give me 2x. If you watched my last video, you notice that I said as soon as I see an x squared term and an x term, that means we're going to factor this in order to solve it. In order to factor, it needs to be set equal to 0. So that means I need to subtract this negative 2x to this side. That's going to give me x squared. Well, 1 minus 2 is 1, and that side's equal to 0. Because I don't have a C term here, I can't use my normal factoring. So I can't find the what's going to add to negative 1 but multiply to 0. Well, I could, but it's going to be a little bit more difficult. But what I do notice is that each of these have an x term. One of the most underrated forms of factoring is to just take out the greatest common factor. So we're going to take out that x, and that's going to leave me with x minus 1. So once again, I just undistributed this x. If I were to distribute it back in, I would get x squared minus x. So that's what we mean by the greatest common factor, is you're undistributing what they have in common. So they both had an x, so I just took that x out to the front. Now, in order to finish solving for x, we know that we set each of these equal to 0. Well, that just gives me x equals 0. And then x minus 1 equals 0, so x should equal 1. To kind of step you through what we did once again, everything that's in green, that's been the logarithm so far. So the logarithm part actually said that we could take the addition and condense these using multiplication. So x times x is x squared, x times 1 is x. The subtraction says that we can condense these using division. So I did 4x divided by 2. That was using the logarithms. Also, knowing that if I have one log on the same side where the base is the same, that means I can cancel the logs and just take the arguments. Everything in blue, this is quadratics. This is how we can solve something that has an x squared and an x term. So once again, biggest thing is making sure that you set it equal to 0. So you subtract anything from this side over, and then you use your different factoring skills to find your two factors, set your two factors equal to 0, and solve out. Now we know for logarithms we're not actually done yet. We have to make sure that our arguments are positive. Positive means greater than 0. So I need to check each of these. I have x plus 1, and I have 4x. I need to put all of these values in. Let's start with 1. If I plug in 1, well, 1's just 1, that's positive. 1 plus 1, that's positive. 4 times 1, that's positive. So x equals 1 is an answer here. Now if I plug in 0, well, 0 is not a positive number, so this does not work. As soon as it doesn't work for any of them, it's out. So even though here if I put it in, 0 plus 1 is positive, because it did not work for this one, also 4 times 0 is equal to 0. I'm going to make that an x. Because it does not work here and it does not work here, it does not work. So x equals 0 would be our extraneous solution. X equals 1 would actually be our solution. Now, before I move on from this, a question that I get often as a math teacher is, will it always be this way? Will we always cancel one of them? And the answer is no. Sometimes both of your solutions will work. Sometimes when you plug them in, both solutions will give you positive arguments all the way across. Both of them would be solutions in that case. Every once in a while, neither of them would work. If neither of them worked, it would just be a no solution equation. And those are okay. So many of the examples we see, it often is one will work and one will not. But you can have equations where both solutions work or where no solutions work.